Okay, welcome back to another video lecture for High School Algebra 2, section 1.6. And in this section, we're going to be talking about solving systems of linear equations, specifically 2 by 2s, which is a two equations in two unknowns. So this means that we're dealing with equations that can be written in the standard form or in the slope-intercept form. And we will be doing this both by substitution and elimination. Now, I find that elimination is usually the preference, at least among students in my school. So when we do substitution, I want to give you a procedure for this that will always work. And it hopefully will make it a little bit easier than some of the traditional ways that we're shown to do substitution. So to begin with, we have a system of simultaneous linear equations in mx plus b form. Here is equation 1, here is equation 2. So when I say solve by substitution, what I mean is to put the two equations that you have into mx plus b form so that they are both equal to y, and then we will set these two equations equal to each other to find the x coordinate, and then we will do what's called back substituting to find the y coordinate. Remember, the answers to systems of equations is an ordered pair with an x coordinate, comma, a y coordinate. So in this system, we're very lucky because both equations are given to us in mx plus b form. So what I mean by get them equal to y is to make your equations look like this. It's y equals and then something. And then the second equation will say y equals and then something. What this enables us to do is to set those two somethings equal to each other. So I'll take the top equation, negative 7x minus 1, taking the expression on the right-hand side, and I will make that equal to the expression on the right-hand side of the bottom equation, x minus 9. What this does is it turns our problem into a problem from section 1.2, multi-step equations, and then we just work the problem in the forwards direction using DCS. So there is no D or C in this particular multi-step equation, so we can jump straight to solving. Furthermore, remember we're looking for fractions in the solving procedure. We'd like to clear the fractions if we have them. Now this system does not involve fractions, so we're very lucky we can just jump straight to the multi-steps that we had in section 1.2. So we'll divide it up. I can add 1 to both sides, having the effect of canceling the 1 off of the left. That gives us negative 7x equals. Then I'll have x and then negative 9 plus 1, which will give me negative 8. I can remember that this is 1x. I'd like the letters on the left and the numbers on the right, so I will subtract 1x to cancel the 1x off of the right, moving it to the left, remembering that this cancellation, because I did that with subtraction, will make a 0. Then I'll have negative 7x minus 1x, which will give me negative 8x altogether equals to negative 8. And then remember, when I have a number times x equal to another number, I can just divide both sides by the number in front of the x. That will have the effect of canceling the negative 8 off of the left. And remember, canceling by division makes 1. So we'll have 1x equal to negative 8 divided by negative 8, which is positive 1. And that is our x coordinate to the solution to this system of linear equations. So then the substitution part of this comes in. All I have to do now is pick whichever equation I like better. I like the second one because all I have to do is take x and subtract a number from it, which is really easy. So I will now copy down what the second expression is. It is x minus 9, and I will just plug the x value that I found in for x. So put a 1 right there, minus 9, that is negative 8 as our other coordinate to the solution of this system. And so this is our answer. So in general, the step-by-step for how to do a system of equations by substitution, at least in this type of equation, is to put them both into mx plus b form, set the right-hand sides equal to each other, follow DCS and solve it like we did in section 1.2 to get the x coordinate. We'll write it down. and then we will back substitute the answer to what x equals to into either one of the equations. You pick your favorite, and that will give us what the y coordinate is. Okay, so let's try one now that is not in the mx plus b form. We'll do 6x minus 5y equals to negative 28. And we'll do 7x plus y equals to 22. Okay. Again, let's assume that we're being told to solve this by substitution. So we have a system of equations, which means our answer will be an ordered pair, x comma y, and we just need to fill in the blanks. Now the problem here is that neither one of these equations is in the mx plus b form. So let's come over to the side real quick with the first equation and figure out what this is in mx plus b form. In other words, I'd like to isolate the y, or in other words, solve this equation for y. So I can do that by sending the x over to the right-hand side by subtracting 6x from both sides. That will give me negative 5y equals 2. Now notice that a constant and an x term do not interact with each other, so we just write down what we have. We'll have negative 6x minus 28. Then I'm going to treat this like this was just a number times a variable equal to another number. So I divide both sides by whatever that number happens to be. That has the effect of canceling the number from the left. Canceling by division makes 1, so that's 1y equal to negative 6 divided by negative 5, which is positive 6 fifths x. And then we'll have negative 28 divided by negative 5, which is positive 28 divided by 5. And so unfortunately, we get this really ugly thing with a bunch of fractions. I can do the same thing with equation 2. We'll have 7x plus y equal to 22. So again, I'm going to subtract 7x so that the x's go to the left. That gives me y, negative 7x plus 22, because remember, a constant and a variable term do not interact with each other. And this one's done. It's done because we didn't have to divide by anything. We already have y equals to something, so we are good to go. Okay, so let's copy down these equations. What equation 1 actually is, I'll call this 1 star, is y equals to 6 fifths x plus 28 fifths. And what equation 2 actually is, call this 2 star, is y equals to negative 7x plus 22. Cool. Now that we have two equations in mx plus b form, remember I can just set the right-hand side of each equation equal to each other. So I will write 6 fifths x plus 28 fifths equals negative 7x plus 22. And this has effectively transformed our system of equations into a problem from section 1.2, which is much easier to solve. So we look for DCS. There's no distribute, there's no combine, so now we're at the solving step. And remember, during the solving step, we would like to clear the fractions if we have any. So I've got two fractions right here, but the good thing is they're both in the same denominator. So I just need to multiply everything by that denominator. 5 multiplies 22 and makes 110. 5 multiplies negative 7 and makes negative 35. So we'll have negative 35x plus 110. 5 multiplies 28 fifths, but notice that the denominator matches the thing that we are multiplying by, so it just obliterates the denominator and leaves us with the numerator. And then lastly, 5 multiplies 6 fifths x, but again, the denominator matches the number we're multiplying by, so it'll just obliterate the denominator and it leaves us with the numerator times x. Now we're ready to continue our solving process. Remember, we'd like to put all the numbers on the right and the letters to the left. I can do this by subtracting 28. That'll have the effect of canceling the 28 from the left-hand side, and then 110 minus 28 will just be 82. So I'll have 6x on the left and negative 35x plus 82 on the right. Then I can add the 35x over, which has the effect of canceling the right-hand side 35x down to 0, leaving me with just 82 on the right. And then I'll have 6x plus 35x, which gives me 41x. Lastly, when I have a number times a variable equal to another number, remember we can just divide both sides by the number in front of the x. That will have the effect of canceling the 41. And remember, canceling by division leaves us with 1x. And then 82 divided by 41 is just 2. So my x answer to this thing is just 2. Well, now I need to find the y answer, so you pick your favorite equation. I'm going to pick the one that doesn't have fractions because it's just easier to deal with. So we will have negative 7 times x plus 22. And what we mean by substitution is we're going to substitute the value of x in this equation with the value of x that we found. So that is 2. So we'll have negative 7 times 2, which is negative 14, plus 22, which is just 8. So this is negative 14 plus 22, and then that is just 8. So my solution to this system of linear equations is just 2, 8. And that is just about as hard as this gets. I know that there's a lot of writing. That's the challenge here, is that it's not that these are actually difficult operations. You notice we are just doing the things that we did in section 1.2, but we had to utilize something that we learned in section 1.4 in order to put it into a format that enables us to do section 1.2 related tasks. So there's a lot of writing, but nothing here is actually all that difficult. You just need to make sure that you write very clearly. If you need to use like a whole problem for a page, do it. Don't try to write in the margins or anything like that just because you're running out of space. The best way to get good at this is to organize your notes in such a way that you're using more paper rather than less so that you can see everything that you did. Lastly, always double check to make sure that your answers work. Now, one thing you'll notice about the substitution method, when we have equations that are in standard form, not mx plus b form, substitution takes a lot of pre-processing work just to enable us to do what we did in section 1.2. And it takes up a whole lot of paper. So what would be easier is the method of elimination. Now, real quick, how do you know that elimination is going to be easier? Well, in general, if you have two equations in the standard form, then we like to try elimination. And if you have a system of equations where they're both in mx plus b form, then we like to try substitution, because substitution is shorter for mx plus b equations and elimination is shorter for standard form equations. So what exactly is elimination? Let's do the same system, but this time we are going to do this by the method of elimination. So we know our answer is 2, 8. Let's verify that elimination produces the same answer. Okay. So elimination, what we're going to do with it is we're going to look at the x numbers and we're going to look at the y numbers. So notice that I have a 6 and a 7 for the x's, and I have a negative 5 and a 1 for the y's. Now, what I'm going to try to do is I'm going to find a number that I can multiply one of the equations by that will turn either the x numbers into each other, meaning I want either the 6 to become a 7 or I want a 7 to become a 6. Or I'm going to try to turn the 5 into the 1 or a 1 into a 5 by multiplying by something. Now, immediately you'll notice turning a 6 into a 7 by multiplying by something is really hard. It involves fractions. So we maybe don't want to do that. Instead, notice that I can turn a 1 into a 5 very, very easily. What I will do is I will just multiply everything in the second equation by 5. So 5 times 7 will give me 35x. 5 times 1 will give me 5y. And 5 times 22 will give me 110. And we'll just call this equation star. Okay, next, what I want to do is make sure that the number that I was able to turn into the other number has the opposite sign. So we turned a 1 into a 5. This is a negative 5. This is a positive 5. If they are both the same sign, then all you have to do is multiply either equation 1 or equation star by a negative 1. In other words, you just switch all the signs. Okay? Then what I'm going to do is I'm just going to write these two equations down right next to each other. And I'm going to add them together. Now view this like it is 1, 2, 3 separate subtraction problems. We can just say, what is 35x plus 6x? Well, that's 41x. What is positive 5y plus negative 5y? Well, that's 0. And then what is 110 plus negative 28? That is 82. So what we have here is actually the equation 41x equals to 82. And then we can do the rest of our DCS procedure, where I divide by 41 on both sides, just like we did in the substitution method, and we get that x is equal to 2. Cool. So once we have x equal to 2, we just pick our favorite equation. I like equation 2, and we will plug in 2 for the x's, and then we will try to, I'm sorry, that's a 7, not a 6. Oops, that's a 7. And then I will try to solve this for the y variable. So notice this is 14 plus y equals 22. And then, of course, I can take 14 from both sides, which I cancel it off of the left, leaving me with 8 on the right. Boom, there's our answer. X is 2, y is 8. And you notice that there's a little bit of process of thinking that goes into this. We have to look at what we have. But for the most part, we are skipping a bunch of the pre-processing steps that we had to do when we were using the method of substitution. So elimination turns out to be better for standard form equations, and substitution turns out to be better for mx plus b equations. So let's do another one. We'll do x plus 7y equals 17. Okay. And then x minus y is equal to negative 7. Okay, so we're going to look at the numbers in front of the variables. And I want for two numbers to be the same. Basically, I want either the x's to have the same number in front of them, or I want the y's to have the same number in front of them. Now we get very lucky here. Notice that the x's already have the same number in front of them. But remember the other part of this. I want one of these equations to have the opposite sign. So if this is a positive one, this should be a negative one. Well, that's a very easy fix. You are always allowed to take one or the other equation and just change all of the signs. Now you have to change all of them, not just one. So that means you have to change the x sign, the y sign, and the constant sign. So we'll have negative x plus y equals 7. Then we're just going to write these things down. 1x plus 7y equals 17. Negative 1x plus 1y equals 7. And we will just add them together. Remember, this is like 1, 2, 3 addition problems. So positive 1 plus negative 1 is just 0. 7y plus 1y is 8y. And then 17 plus 7 is 24. So what we actually have here is 8y equals 24. And then if I divide both sides by the number in front of y, that cancels the 8. Remember, canceling by division makes a 1, so we'll have 1y equal to 24 divided by 8, which is 3. So remember, my solution here is an x, y ordered pair, and we just found out that y is 3. So then I'm going to pick my favorite equation. I'm actually going to use the second one, which was x minus y equals to negative 7. And we're just going to plug in the y value now instead of the x value because what we found was a y value. So that will say x minus 3 equals negative 7. Well, at this point, I can just solve, add 3 to both sides to cancel the 3, leaving me with an x. Negative 7 plus 3 makes negative 4. So my ordered pair is negative 4, comma, 3. Okay, and I hope you see that the elimination method is quite preferential, and that is because it's really, really easy to do with standard form equations, and we can skip a lot of those steps. So let's do one more here. And in this one, we'll actually have to multiply by something. So we will solve 4x minus 9y equals negative 42. Intersected with x plus 5y equals 4. Okay. So we begin by looking at all of the numbers. And remember, we want either the x's to have the same numbers or the y's to have the same numbers. Well, turning a 9 into a 5 or a 5 into a 9 is really difficult. It involves fractions, so we won't do that. Instead, I can notice that I can turn a 1 into a 4 very, very easily. I just multiply everything in this second equation by 4. So we'll make this star equation by multiplying 4 times 1, 4x, multiplying 4 times 5, 20y, and then multiplying 4 times 4, 16. Then we would like to make sure that either equation 1 or equation star have opposite signs of each other. So these are both 4s at this point, but one of them has to be negative. I've already written this one down. So remember, what we're going to do is we're just going to write the star equation and equation 1 down together. But I need this to be the opposite sign, and we're always allowed to just change the signs of any of the equations so long as we change all of them. So this was positive, we make it negative. This was negative, we make it positive. This was negative, we make it positive. Then this is one giant addition problem, and it's technically 1, 2, 3 separate addition problems. 4x plus negative 4x makes 0. 20y plus 9y makes 29y. 16 plus 42 makes 58. All right, so this is 58. So we actually have the equation 29y equal to 58. Okay, so if I divide both sides by 29, that cancels the 29 off of the left-hand side. Remember, cancellation by division makes 1y equal to 58 divided by 29, which is 2. So we have found that the y coordinate is 2. Then I'm going to pick my favorite equation, either equation 1 or equation 2. Again, I like equation 2. So that's 1x plus 5, and I'm going to plug in the value I found for y. So 5 times 2 is equal to 4. Okay, so 5 times 2 is just 10. And then I can get the x by itself by subtracting 10 from both sides, which will cancel the 10 off of the left-hand side, leaving with 1x equal to 4 minus 10, which is negative 6. And boom, our answer is negative 6, comma 2. Okay. So remember a couple of key things from this section. Substitution works best when you have two mx plus b form equations given to you in the problem statement. Elimination works best when we have two standard form equations in the problem set. Most people prefer elimination. Just notice that there is some more thinking that is happening in here. So if you're not super good at your multiplication tables, you may want to look those over a few times to try to make sure that you know what all the multiples of different numbers are, because you do have to have a good amount of procedural fluency with that in order to tell what you have to multiply one or the other equation by. And you can try to get the 5 to turn into a 9 and vice versa. It still works. It's just that the numbers that you're dealing with will be fractions then, and they get pretty nasty pretty fast. So you always want to look for the easiest way out. If you understand those things, then you understand section 1.6.